Okay, this section is about complex fractions. Okay, fraction has numerator and the denominator. And complex fraction is a fraction that has numerator, fraction in the numerator, or denominator, or both. So a over b divided by 3. So this is a complex fraction because the numerator is a fraction. Also a over b divided by c over d. So the numerator and the denominator both have fractions, or the numerator is just a number, or the denominator is a fraction. So these are all complex fractions. So when we do simplify the complex fraction in this example, we can rewrite this. So this fraction is a division, so we can rewrite this with division. So the numerator is divided by the denominator, 25 over 8. Okay, then since there is a division, we can convert this division into product. Then we need to make a reciprocal of this fraction, 8 over 25. Okay, so this complex fraction can be written as this. The numerator stays the same, but the denominator became reciprocal. So we can write this division into product by making the denominator, the fraction in the denominator, reciprocal. Okay, then once we simplify this, we can reduce. So 15 and 25 both can be divisible by 5. So divided by 5, then 3 divided 25 by 5 is 5. Okay, how about 8 and 14? The common factor is 2, so we can divide this by 2. So 8 over 2 is 4. 14 over 2 is 7. And all the factors does not have a common factor, so the answer is 3 times 4. Okay, so that's it. So 12 over 35. So for a complex fraction, let's say here is an example, a over b. Okay, let me erase. Okay, a over b divided by c over d. Then you can write it as a over b times reciprocal of this fraction, d over c. Or you can do this way. Here is a over b over c over d. Okay, the longer bar is the main fraction bar, main fraction line. Then you can write it as this. You can multiply the top and bottom, the outer terms together, so AD, over multiply the inner terms, B and C. So you can write it as this. So outside terms, outer part divided by the inner part. See, so this is a product of outer terms. So product of outer terms over product of inner terms. So we can say when you simplify a complex fraction, we can apply this poopy. So product of outer parts over product of inner parts. Or you can do this way, write the fraction, the numerator, multiply by reciprocal of the denominator. Okay, so let's try exercise 4. Okay, this exercise 4 is the numerator is 36x to the 4th power over 5y to the 4th power z to the 5th power divided by 9xy squared 20z to the 5th power. Okay, so the numerator is one single fraction, denominator is one single fraction. So we can use poopy or the first one, this one or this one. Okay, let's use poopy. So there will be the numerator, the outside terms, multiply the outside terms, so 36 x to the 4th power times 20 to the z to the 5th power over the inner terms, inside terms, the inside part. 5y to the fourth power, z5, and then 9xy squared. Okay, then simplify. So the numbers use different color. So 5 and 20, you can divide by 20 by 5, then 4. Okay, 36 and 9. So 36 divided by 9 is 4. Okay, how about x? X, we have 1x here. So we have 1x, so we can cancel out this 1x. The subtract 1 from 4. Okay, so let me write the result. So the numerator is 4 times 4 is 16. And x term is z to the, so x term is x. So x to the 4 minus 1 is third power. How about z? Okay, z5 cancel out. Here, and the denominator has y to the fourth power and the square. So y to the 4 plus 2 is 6. So this is the simplified expression. Okay, for this exercise example, okay, this is the fraction bar. So the numerator and both numerator and denominators are fractions. So this is complex fraction. Then this is equal to, okay, you can apply B or you can write the numerator multiply by, okay, divide, this is divided by something. So once we make this one multiplication, then reciprocal, make the reciprocal of the denominator. So the denominator will be, reciprocal is 10x cubed, switch these two, 10x cubed over 2y squared. Okay, then the denominators are, okay, 5x squared is 25x squared times 10x cubed over, okay, 2 squared is 4, y squared. And then simplify. Okay, this is 2. So this is equal to, use a different color. Okay, so 4 cancel out. Move y squared to the numerator, then 3 minus 2. And then divide 10 by 5 is 2. 25 by 5 is 5. Move x squared to the numerator, then 3 minus 2. So this is equal to 2 over, okay, numerator is 2, bottom is 5. The numerator y to the 3 minus 2 is 1. And x, 3 minus 2 is 1. So this is the simplified form. Okay, in this example, okay, let's simplify this complex fraction. So why don't we use B? Multiply the outer part, x plus 1 times x plus 5 over, multiply the inner part, x plus 2, x plus 1. Okay, then as we can see here, we can cancel out x plus 1. So the numerator is x plus 5 over x plus 2. Alright, so in this case, what is the restrict values? What are the restrict values? Okay, we get those from the denominator. So here is, okay, for the numerator, this is the denominator. So from that one, x cannot be equal to negative 2. And from the fraction in the denominator, x plus 5 is the denominator. So we know that x cannot be equal to negative 5. Okay, then once we make this one reciprocal, now x plus 1 becomes denominator. So this one becomes denominator. So we know that x cannot be also negative 1. So in this case, for the complex fraction, the restrict values comes from all these 3 parts from the bottom. From this, all these three parts is used to find the restrict values. Okay, this is the exercise number 9. Okay, so let's simplify this. The denominator is actually over 1, so we can apply B. So 25x squared times 1 over x minus 5 times 5 plus 4x minus x squared. Okay, in this case, let's check. All right, you know what? I copied the question incorrectly. So let me erase this one and then write the correct question. So the denominator of this complex fraction is 10x over 5 plus 4x minus x squared. So this is equal to, multiply the outside part, so 25x squared times 5 plus 4x minus x squared. 5 plus 4x minus x squared divided by the inner part, x minus 5 times 10x. Okay. And then make sure that we need to factor this trinomial. And this trinomial is in ascending order, so it is still fine. So 5 can be written as 5 times 1, and x squared is negative x times x, and then we can put the negative sign here. So that this product is negative x, this diagonal product is 5x, sum is 4x, which is same as the second term. So we can write the trinomial as 5 minus x times 1 plus x. 5 minus x times 1 plus x over x minus 5 times 10x. Okay, do you remember last time? Okay, for the subtraction, if you switch this a minus b, switch it, then you have to put the negative sign. So 5 minus x, this is x minus 5. If you can switch this one, then it becomes x minus 5. This will become x minus 5. So we gotta put the negative sign. So actually this cancel out and becomes negative. Okay, and then simplify, reduce the numbers. So 25 over 5 is 5. 10 divided by 5 is 2. So the answer is, okay, we can get rid of this x. So subtract 1x. So 5, the numerator is 5. X, 2 minus 1 is the power is 1. And then for this addition, you can switch these two. X plus 1 over the bottom is 2. So this is the simplified expression. Okay, in this example, the denominator can be written as 2x plus 1 over 1. So we can apply B. So that is equal to x squared plus 4x plus 3 times 1 over the inner parts are x minus 2 and 2x plus 6. So we can factor each part. The numerator is x times x, 3 is 1 times 3, and the sum is 4x. So the numerator is x plus 1 times x plus 3. And the denominator, we can factor this, x minus 2 times factor out 2, then x plus 3. So from here, we can cancel out this x plus 2, x plus 3. So this is equal to x plus 1 over, write the number first, so 2 times x minus 2. Okay, how about the restrict values? Okay, the restrict values comes from all these three parts, except the first part. So, okay, this is the first part, and this is the first part, This is the first part. So we will get the restrict values from all these three parts. This one, this one, this one. But one cannot be a 0, so I'll leave it. So we can find zeros from here and from here. So the restrict values are x cannot be equal to 0. 2 and x is not equal to, from here, okay, this one is same as this one, so cannot be equal to -3. Okay, how about the previous one? For the previous one, okay, we can find the restrict values from all these three, except this one, except this. So we gotta find it from this one, and this one. And this part is same as this guy. So we cannot make this one equal to 0, not equal to 0, this is not equal to 0, and not equal to 0, not equal to 0. So the restrict values are, okay, from the, there are so many things. So x, okay, let me use this one. So from this, x is not equal to 0, and from this, x is not equal to 5, and from this, x is not equal to -1, and from this, same as x is not equal to 5. Okay, let's simplify this complex fraction in exercise 21. Okay, so we're gonna write using PUPI. So write a product of outside expressions, x squared minus 3x minus 10 times x squared minus 5x minus 14 over x squared minus 4x plus 4 times 21 plus 4x minus x squared. Okay, and then let's factor each trinomial, each part. So this one is x times x, 10 is 2 times 5, and we gotta put the negative sign, so -5. So the sum is -3x. So let me write it over here. So this is x plus 2, x minus 5. Okay, this trinomial is x times x, -14 is 2 times 7 is 14, and put the negative sign on 7. So this is 2x, this product is -7x, so positive 5, so -5x. So the expression is a product of x plus 2, x minus 7. Okay, and this one, x times x, 2 times 2, and both negative. So -2 times -2 is positive, the sum is -4. So this is equal to x minus 2 times x minus 2. Okay, finally this one, okay, 3 times 7, x times x, negative sign on x, the below. So this is 7x, this product, -3x, sum is 4x. Okay, so this is equal to 3 plus x, 7 minus x. Now it's time to reduce. X plus 2. Do we have x plus 2? No. How about x minus 5? No. How about x plus 2? No. How about x minus 7? Yes, we do. X minus 7. So switch this one, then x minus 7. So we can cancel out. It becomes -1. And then unfortunately, there is no x plus 2 and x minus 2. So leave it. So the answer is, so that is equal to, the numerator is x plus 2. There are 2 of them, so squared times x minus 5. The denominator is x minus 2, 2 of them, so squared. And then from this one, we write x term first, so x plus 3. And then make sure we put the negative sign outside. Negative sign outside. Okay, then what are the restrict values? So we get the restrict values from all other 3 parts. So from here, 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 and here. So x is not equal to -2 and 7. From this one, +2. From this, -3. From this, and positive 7, which is over here. Okay, this example is a little bit different from the examples in above, because the numerator and denominator is an addition and subtraction, so each term is also fraction. So in that case, we can get rid of each denominators of each fractions. So we will use this method. Here is fraction a over b. It is okay that we can multiply the numerator by some number and denominator by some number. So this is equivalent to a over b. So we're going to multiply the same thing. We're going to multiply the numerator and the denominator by LCD. Okay, so what is the LCD? So the LCD is, so we get the LCM from each denominator of these fractions. So the LCD is 3x. So we're going to multiply the whole numerator by 3x, whole denominator by 3x, which means once we distribute, we multiply all the terms, multiply all these terms by what? 3x. So multiply this by 3x, multiply 2 over 3 by 3x, multiply 1 by 3x, and negative 2 over x by 3x. So we multiplied each term in the numerator and denominator by 3x. So that is equal to, okay, for the first expression, we can cancel out 3, so x times x is x squared. For this one, 3 cancel out, so we have 2x. How about the denominator? 3x times 1 is just 3x, minus xx cancel out, 2 times 3 is 6. So the 4 terms does not have fractions anymore. And then simplify the numerator and denominator. Factor the numerator and the denominator so that we can simplify. So factor out x, then x plus 2 over the denominator. Okay, factor out 3, then x minus 2. Then there's no common factor, so this is the simplified expression. Okay, how about restrict values? Okay, we get the restrict values from denominator, right? So this is the denominator, so we can set this is not equal to 0. Then what? X equals 2, right? So x equals 2. So x should not be equal to 2 because 3x equals 6. 3x minus 6 equals to 0. Then 3x equals 6. So x equals 2. So x should not be equal to 2. And also, if you can see here, this is the denominator of this fraction. So x cannot be equal to 0 as well. Okay, let's try another one. Okay, this is exercise number 30. Okay, the numerator and denominator has fractions, and x minus 4 is the denominator. So the LCD is x minus 4. So what I'm going to do is multiply each term by x minus 4. So multiply this 4 by x minus 4, and this fraction by x minus 4, 5 times x minus 4, and even this fraction by x minus 4. Then this is equal to, okay, the first one is x 4 times x minus 4. The second expression is cancel out x minus 4, so that is equal to 16 over 5 times x minus 4 plus x minus 4 cancel out, 20. And then the numerator is distribute to remove the parentheses for x minus 16 plus 16 over 5x minus 20 plus 20. Then this is equal to 4x. These two cancel out, 0, cancel out 5x. And then xx cancel out 4 over 5. Okay, that's it. How about the restrict values? X cannot be equal to what? From here, we know that x cannot be equal to 0, so not equal to 0. And from here, from this denominator, this fraction, x should not be equal to what? Negative 4. Okay. Alright, so in this example, we will do the same thing. Find the LCD of each fraction and then multiply each expression by the LCD. So this is the denominator, x plus 2, and x. So the LCD is x times x plus 2. So from here, the LCD is x times x plus 2. So multiply each expression by the LCD. So multiply this fraction by x times x plus 2. Multiply this fraction by x times x plus 2. And also this one, x times x plus 2. Okay, then that is equal to, once we multiply each expression by the LCD, the denominator will be removed. So x plus 2 cancel out. So we'll have 2x over x plus cancel out, 3x plus x removed, so 2 times x plus 2. Okay, then numerator is 2x, denominator is 3x plus 2x plus 4. Use the distribution. Then 2x over, combine the like terms, 5x plus 4. And then this is all. This is it. So that's the expression. Now how about the restrict values? Okay, we get the restrict values from the denominator. So we can get it from what? This is denominator. So this one cannot be equal to 0. So x is not equal to what? Negative 4 over 5. Move 4 to the other side. Negative 4 and then divide by the coefficient of x, 5. Cannot be equal to this. And how about this? How about the original fraction? So x plus 2 cannot be equal to 0. So x should not be equal to negative 2. And from this one also x is not equal to 0. Okay, this is exercise 36. Okay, sum of the expression has negative power. So if we have a negative power, something like this, negative power, then we can move this to the denominator so that the exponent becomes positive. So why don't we change the negative exponent form so that we can move it to the bottom so that it becomes positive. So 3 over, can move x to the negative 2 power to the denominator, then x squared minus x over, even this one, 4 over, the denominator becomes x to the first power, which is positive 1, and then plus 6x. Okay, so from here, let's multiply each term, each expression by the LCD. So x squared is denominator, x is the denominator, so the LCD is what? X squared. So multiply each term by the LCD. X squared, this is x squared times x squared. Then this is equal to, okay, so x squared cancel out, 3 cancel out, 3 minus x, 1 plus 2 is 3 over 4, okay, cancel out 1x, so 2 minus 1, then x to the first power plus 6x cubed. And the numerator is not factorable, so write it as it is. And the denominator, you can factor out 2x, then 2 plus 3x squared. So this is the simplified form. And the restrict values are x cannot be equal to, from here, 0. From here, well, this is always positive, right? Because x squared is positive, so positive plus a positive number this is always positive. So we cannot find restrict value from this one. It's okay. And from the original, so from this one, this fraction x, denominator x cannot be equal to 0. Okay, and then even this one. So This is the restrict value. I skipped example 5, letter B. So let's simplify this. And this is similar. This is very similar to the exercise that we just solved. So this is okay. So negative power, negative exponent. So let's make it positive. So 5 plus 1 over. You can put this to the denominator. Then the exponent is positive 2 over even this one. Move x to negative 1 to the denominator. Then it becomes x to the first power plus x. And since the LCD is x squared, multiply everything by x squared. X squared, x squared, and x squared. Then the numerator will remove all the denominators. I mean the expressions in the numerator, fractions in the numerator. So there will be 5x squared plus x squared cancel out, 1. Denominator, 8. 1x cancel out, so 8x. Plus x times x squared is x cubed. So the numerator is already a prime. And the denominator, we can factor out x. So 8 plus x squared. So this is the expression. And how about from this expression, you can switch this x squared and 8 if you want to write variable term first. But usually we write the variable term first. So x times x squared plus 8. How about the restrict values? The restrict values, okay, this factor cannot be equal to 0. So x is not equal to 0. And from this binomial is always positive. So it cannot be a 0 anyway. For any real number x, this binomial is positive because x squared is positive plus positive number is positive. Okay, how about this one, this fraction? So this denominator x should not be 0, so same as this one, and even this, so x is not equal to 0. Okay, in this is exercise 32. Okay, in this expression, the LCD is, because these are the denominators, so the LCD is y times 2y plus 1. So we'll multiply each fraction by this LCD. So multiply this by y times 2y plus 1, y times 2y plus 1, y times 2y plus 1. Okay, then this is equal to y cancel out. So y times 2y plus 1 minus 2y plus 1 cancel out. So we have 2y only, 6y. And from this denominator, 2y plus 1 cancel out. So we have 5y. Okay, then simplify the numerator. Remove the parentheses using the distribution property. So 10y plus 5 minus 6y over 5y. And this is equal to, combine the like terms. So 10 minus 6 is 4y plus 5 over 5y. So this is the expression. And how about the restrict values of y? So from this, y cannot be equal to 0. And then from the original denominators, this is should not be equal to 0. So y is not equal to negative 1 over 2. Move 1 to the other side, so over 2. And even this one.